Pulling tug at 8.6. When I look at these circles, I know the basic area of a circle is the radius squared times pi. So this shaded region is this larger circle, but then they cut the smaller circle out of the middle. They were a little tricky with this. Notice that the larger circle, 10, is only this distance. So I have to actually find the whole distance. So the larger radius is 10 plus 2, which is 12. So I want to take the area of the larger circle, so 12 squared pi, subtract out the area of the smaller circle, 2 squared pi. So I get 144 pi minus 4 pi, which means the area is 140 pi, and then it's with centimeters, so centimeters squared. I thought that was a little bit difficult to see on the copied test, so I did not count it against you if you thought that the radius of the large circle was 10. The area of the shaded sector. Well, the whole circle has 360 degrees. First thing I need to know is find this angle measure of the shaded sector. So it's 360 minus 240, which is 120 degrees. So this shaded part is a fraction of the circle. It's only 120 degrees out of the entire 360. And I want to find that area of just that fractional part. So the degrees of the fractional part over the total degrees equals the area of the fractional part over the total area. Well, the total area of this circle will be radius squared times pi. So I end up with 1/3 when I reduce that fraction equals a over 36 pi. Cross multiplying gives me 3a equals 36 pi. So a, when I divide both sides by 3, ends up being 12 pi in its area, so it's inches to begin with, so square inches. When I look at this, I notice that this shaded part really is this sector of a circle, like this one over in 12, but then with this triangle cut out of it. So the area of the sector, using the same kind of work we did over here, this is 90 degrees over the entire 360 equals the area of the sector over the area of the entire circle, which would be radius squared times pi. So 1/4 equals a over 25 pi. Cross multiplying gives me 4a equals 25 pi. So a equals 25 pi over 4. Just divide both sides by 4. Now, that's the area of this whole part. I just want the area of this segment, so I need to find the area of my triangle now, so I can subtract it from this area. Well, area of a triangle is 1/2 times the base, which is 5, times the height, which is also 5. So I end up with 12.5. So the final area of the shaded segment, and I'm going to have to put this up here because I don't have room, I would take the area of the whole sector, which is 25 pi over 4, and I'd subtract out the area of the triangle, which is 12.5, and then my units are on this entire thing, so that's square centimeters.